Hello. For this video, we will be discussing the evidences for continental drift theory. But first, let us recap what we have so far. So in Module 1, we looked at what the relationship is of the epicenters, location of volcanoes and mountain ranges with respect to where the plate boundaries are. Okay? And then in Module 2, we looked at the interactions of these plates in their boundaries. So, what are the three types of interactions that each can have, that each situation would have, and how do the segments behave in each interaction? Okay. Now, in Module 3, we kind of looked at what the geological features are that will be formed when you have these different interactions. Okay, and then in module 4, we looked at the theories that kind of explain why the plates, right, move and do these kinds of interactions, right? So along that discussion, we were able to uh, mention concepts like the continental drift theory, the seafloor spreading theory, um, and convection currents and the internal structure of the Earth. Now, we kind of explained what the theories are, but we never really presented what the evidences are. That's because the evidences are discussed in Module 5. Okay, so with starting now, we will start to discuss what those evidences are that were presented for continental drift theory. Okay. So first of all, what is this continental drift theory? So let us review. Please remember that a fellow or a scientist named Alfred Luther Wegener proposed this theory that the continents of the world actually shifted or moved along the surface of the earth. And again, evidence wise, as was explained in Module 4, evidence wise, um, Alfred Wegener was able to present very good evidences, lines of evidence for his theory. The only problem was he was not able to explain why the continents move. So, what were those evidences that were so convincing? Okay, number one, he observed that the edges of South America, the edge of South America and Africa, seem to fit together like a gigantic jigsaw puzzle. Okay, now in fairness, it's not actually Wegener who actually saw this first. So a lot of scientists actually already noticed this. However, it was him who was credited because he was the one who proposed a theory for it, right? So he was, you could say he was the one who formalized that observation, okay? Even if some people already did notice that, okay? So moreover, if you go beyond, Africa and South America, you can even fit all the continents together, okay? Although you have to set the depth at different settings, but you can fit them together if you want. Okay. Second evidence that he presented in order to prove his point was this fossils, right? So, for example, in South America, the southern tip of South America, you find this fossil that we call a Mesosaurus. And on the tip of Africa, you also find a similar fossil of Mesosaurus. And this baffled the scientists because, if you know, in between these two continents is a big ocean. And therefore, and this is a freshwater reptile. Freshwater, keyword freshwater. So therefore, it only lives in freshwater. It couldn't swim across the ocean. And if it's indeed swam across the ocean, then we would find all of these fossils on on the northern tip of South America and all other continents. But the fact that you can only see the fossils in the southern tip of South America and the southern tip of Africa, that gives kind of a hint, right? And by the way, maybe you're also wondering, like, how would the scientists know that it's a freshwater reptile? Well, there are a lot of tricks for that. For example, they could find uh, certain debris inside the stomachs or inside the cavities of the fossils, and if they see species that are from the freshwater and no species from the salt water, that means it's a hint that that creature was a freshwater reptile during the day, during the time. So evidence. So the first one was again the jigsaw fit of the continents. The second one is fossils. Okay, and it doesn't stop at Mesosaurus. In fact, you could have Mesosaurus again connecting the tip of South America and the tip of Africa. Then you can also find Sinognathus or Sinognathus. Um, I think both pronunciations are accepted, and this is another reptile-like um, fossil that you can see connects Africa and South America. And mind you, these two continents now are very far apart. Then you can also have a reptile, the Listersaurus, and that Listersaurus connects Africa, India, and Antarctica. Okay, and then uh, so this one is a reptile. So again, reptiles do not really are not really known to swim across big oceans. So the fact that you can find it in Africa and India and Antarctica, that means there's something that happened in the past, and it's not just because the animal was able to swim across the oceans. Okay, and another convincing evidence was this Glossopteris. So it's a fossil fern, and this is a gigantic fossil fern. So it's a big fossil fern, and it's cone because this is a plant that produces cones, right? So the cone, which would serve as the propagating agent for it to generate new offsprings, the cone that's produced is very big. So if it's very big, it couldn't be, say, blown by the wind and reach the next continent. Okay, but the fact that you can kind of see a line where where all of these Glossopteris fern fossils are found, so that gives you a hint that maybe the continents were once connected together. Okay, and uh, there is no other way to explain all this connectedness, right? Because I mean, now it's easy to imagine that if we have a breed of cat in New Zealand, you can have that in other parts of the continent of the earth, because in other continents of the earth, because we can now travel, and we bring our animals with us, and so animals can spread across different continents. But during the day, I mean, during the ancient time of these animals, it's quite an impossible feat to do. Okay, so that's the second one, the fossils. Then the third one was Wagner was in a lot of expeditions, and he was looking at very different rock evidences from rock. So one of it is, for example, you can find matching mountain ranges, for example, in the tip of South America and tip of Africa, and many other things. And it's not just mountain ranges, but really rock layers. You see, when rock layers are formed, they form a unique pattern. It's like a fingerprint, right? unique only to that structure. Okay? So if you find a pattern like this in another part, in another continent, and also the same structure is found in another continent, there's no other explanation. That means those two continents must have been connected in the past, and something happened that made them drift away from each other. Okay, so obviously in this slide, the only example is matching mountain ranges, but again, rock layers, even composition of layers, even the type of sediments that are in the rock layers. Again, we call that the fingerprint. Uh, I mean, it's like a geological fingerprint. So there are no areas in the world that would have the same pattern, the same composition, if they were not formed together. So the fact that you find those rock layers in this continent, and also the same exact composition and layering and pattern and sequence of patterns in another continent, it means those two structures must have been created at the same time. And again, something just happened that made them drift away from each other. Okay? So again, you have the jigsaw fit of continents, you have evidence from fossils, and then now we have rock formations. So, how about the fourth one? The fourth one is we see different evidences uh, related to climate, and one of it are the coal deposits in Antarctica. So if you look at Antarctica, I can actually pull up this one here, you can see that Antarctica is in the South Pole, right? And the reason why it looks white is because it has a lot of glaciers in it because of the cold temperature. You see, the South Pole is not illuminated by the sun all the time. It's some parts of it are only illuminated 6 months at a time because of the Earth's tilt, right? Because the sun is here, the Earth is tilted like this, so there will always be a part that is hidden from the that is under the shadow of that Earth for 6 months, until and 6 months, because for example here the Earth is like this, it's this end is forward facing, right? So this will be illuminated for 6 months, this one will not be illuminated for 6 months. But then as the Earth rotates like this, now it's the reverse. This end, because the sun is here, is illuminated, but the other side is not. So, but the point is, it's very cold there, so you have ice, and in fact, you don't see a lot of humans in this area except for scientists that are exploring, doing some ice core drillings to get a hint of what the climate was in the past. But there are no living creatures here because it's so cold, right? And then they discovered that there are coal deposits. Okay, so what is coal? So coal is actually formed from plants as they die, and if they're buried in swamps, right? So take note, coals are formed from plants as they die when they are buried in swamps. So the keyword there is plants. So there must have been plants in Antarctica, because otherwise, how can it form coal? So science, chemistry has found out that if you have plant material, like a lot of fiber stuff, and other components of organic material, if you bury it and it's in an environment where oxygen cannot penetrate, because it's in a swamp, it's in a swamp, it decays, but in a fashion such that it doesn't decay like how we see things decay on the surface of the crust, which is, flesh would rot and it would decompose in our right in our very own eyes, given a few days or months. But in that case, the plant material actually decays, but when it decays, it becomes coal, which is a fossil fuel, right? And the reason why it's called a fossil fuel because see, fossils are remains of living organisms in the ancient time, right? So in if you are in mm, probably paleontology or archaeology, fossils are, you know, living things that things that living things leave behind that gives us a hint about what their structure is, what their physical characteristics are. But if in other fields of science, fossil is has a loose term, has a loose meaning, and that loose meaning is any remain, right? Whether it be hinting to what the structure and or anatomical configuration of the organism is or not. So in the case of coal, they are remains, but they are decomposed remains, but again, not in a way that we see how that we see how living things decompose, but it's a way of decomposing living things in a low oxygen environment, and they become coal, which is a fossil fuel. So what's the point? The point is, for coal to have formed in Antarctica, there would have been plants and a lot of it. But how can there be plants in Antarctica if it's covered in ice in glaciers? Okay, so that's the key argument there. That means Africa Antarctica would have been not in the South Pole in the past. Maybe Antarctica was closer to the equator. And then Alfred Wegener, because the continents drifted, now we find Antarctica in the South Pole. Okay? So you have jigsaw fit of the continents, you have evidence from fossils, you have evidence from rock, and then you have the coal deposits in Antarctica. Okay, because there's no other explanation for that. By the way, this is also an addition to evidences from rock. When Antarctica was here a few million years ago, or hundreds of millions of years ago, it's thought to be connected to South America, Africa, India, and Australia. And when these glaciers, right, migrated, they can actually form scars on the rock underneath it. And those scars, we call them tillites or tilites, um, give us a hint of how the glaciers were moving, and in turn informs us that all of these continents were actually connected. Okay, so that's an additional one to the evidence for rocks. Uh, this is also demonstrating the same thing. It's looking at the ice sheets. So therefore, now that completes your your evidences. So you have jigsaw fit of the continents. You have evidence from fossils. You have evidences from rock, including the ice sheets, the tillites, and then you have coal deposits in Antarctica. Because again, there's no explaining why Antarctica would have had plants in it when in fact it's very cold right now. Okay, so those are the evidences of Wegener. If you research more, you can actually find more, but my basis was just this, was your learner's material, because if we try to mention all the other evidences, you would have a lot of things to memorize now. So I think for your level, for high school level, it's enough for us to know only those evidences. Okay? But there are certainly more if you research on it. So with that, what I'm trying to say is that's why they could not do away with continental drift, although it had a glaring weakness, which is it could not explain why the continents would move, what's the mechanism for the movement of the continents. But in terms of evidence, the evidences are solid, right? So, that's science class. You don't have to be able to explain everything as long as you can present evidence supporting it. In fact, because I'm a physics, fan, in fact, that is what is happening right now with quantum mechanics. In quantum mechanics class, when you learn it, it doesn't make a lot of sense. You can't answer why, but the evidence is there. So when they say, an electron simply pops in and out of existence, it's not logical. We could not explain why that is. Just like how Wegener could not explain why the continents would move. But evidence wise, when they do experiments in quantum mechanics, they indeed see, or at least, can infer from the data that they have, that electrons really do pop in and out of existence. Okay? So that's why quantum mechanics is accepted right now, even if, um, nobody can explain why or what's the logical intuition behind it. Okay? But the only difference is now scientists have learned from the case of Wegener and other cases in science that it doesn't really have to have an explanation that is logically sound. It just has to have a lot of evidences, um, you know supporting it. um, I know this is hard to understand, but let me give you maybe an analogy. The analogy is like this: what if you are able to time travel, right? And then you time travel to the time where radios, cell phones are not a thing. So maybe in the 1500s or something, right? And then now you explain to one scientist in that time, or maybe as far back as maybe the Stone Age or something like that. Then you have cell phones, and considering cell phones work, obviously it should not, because there are no cell sites during that time. But just try to understand my point. Just assume that the cell phones work. So my point is this: what if you say to the Stone Age person that this is a cell phone, and it makes us able to communicate between the two of us, even in far distances. Obviously, it will blow the mind of that person. The person would say, it's not possible. We have not experienced that. We could not explain what that is. Okay? But you can convince him by simply making an experiment. And the simple experiment is, um, give me a random string of words, and then I will use my cell phone to tell those random string of words to my companion, which is kilometers away. And then when he comes back, you can ask him the words I told you, what I told you, what you told me, so that you can confirm that I can indeed communicate through this device. Okay? So if you do that experiment a lot of times, the Stone Age person would understand that the claim is true, that I can indeed talk to the person through that device, even if it will blow his mind. He will not understand why that is, because at that time they don't have any concepts of electromagnetic waves, of signals, right? But the evidence is there. He cannot deny the evidence that no matter how we randomly string words together, the other person would know, just because I'm talking to that device, right? So, evidence wise, he cannot deny that what I'm claiming is true, but logically speaking, he would not understand it yet, right? So maybe it's not yet time for him to understand it. So that is how science works. Sometimes there are theories in science that believe it's true, even if the logical explanation is not that sound, because evidence supports because a lot of evidence support its claims. Okay. um, So I think that would be all for this video. We will I will be uploading another video discussing about seafloor spreading next.